On this fourth exam item, we have a simply supported beam where the cross section is an I-shaped section that is comprised of two flange plates that are 10 inches wide by 1 inch high and a web plate that is 42 inches high and a ½ inch thick. This is a doubly symmetric cross section, so of course the neutral axis will be for elastic behavior always at the centroid, but that centroid is going to be located at half the height. And to go and find the maximum applied shear flow, which is little q equals capital V times capital Q over capital I, we need each of those three quantities. All right, so let's go find first our second moment of area, and we'll do that with the parallel axis theorem. Take the web plate first, 1/12 of the base of a ½ inch times the height of 42 inches cubed. Its centroid is at the neutral axis, so the 80 squared term is going to be 0 there. That'd be area of the web plate, which is not 0, but the other term is 0, so we don't need it. And then we have two flange plates, and we have another 1/12. Their base will be 10 inches times 1 inch cubed, plus their area, 10 inches times 1 inch, times their moment arm, which is going to be from their centroid down to the neutral axis, and that distance is 21.5 inches. And that will get squared. Right? When you work this out, this portion down here to the right, just for the flange plates, both of them taken together will be 92.46 inches to the fourth. And then the first part will be 3,087 inches to the fourth. Right, for a total then of 12,333.6, but rounded up to 12,334 inches to the fourth. Right, we're asked again to find the maximum Q, which could be a combination of V max Q over I. Now I for the cross section doesn't vary. Capital Q for these welds doesn't vary either. So we got to find our maximum shear. If you're not sure that where it happens, then okay, we'll be stuck with having to do a shear diagram, and then our reactions for the associated with the distributed load are WL over 2 either side, and so our shear diagram then looks like so, where the peak will be WL over 2 minus WL over 2 for our shear diagram. So in other words, our V max equals WL over 2. That's 5 kips per foot times 35 feet over 2, and that will be 87.5 kips. So the only thing left to find is our capital Q. That's the first moment of the area that is sitting outside of the point of interest. So that's this flange area only, flange plate, and so that area is 10 inches by 1 inch. Its moment arm, 21.5 inches, the same as when we were doing the 80 squared term before, it turns out. And so that's 215 cubic inches, and that allows us to find our shear flow at the welds. Now that's two welds, so we might want to be taking account of that. We've got 87.5 kips for the shear, 215 cubic inches for Q, 12,334 inches to the fourth for the second moment of area, and that will come out to be 1.52 kips per inch for 2 welds. We were asked to find it for 1, so we'll just take half of that. And our answer then is 0.76 kips per inch.